I will be your magic unicorn, and we are going to continue with it'll be the 228 series of the 1001 scripts in Python, but a lot of these are just going to stay as A, B, C, D, E, F, G parts as we learn the Python for Rhinoceros primer that was made by Daniel Rutten years and years ago, and we're definitely going to stay to what I've shown people is you want to go into Tools in your Rhino window, go down to Python script and hit Edit. We're going to stay to this editor. We're not actually going to take any of these. This might be the first one I attempt to take over into a Python node right here, and I haven't done that yet, but basically I'm pairing this series with the math 128 series, basically applying these scripts to GHScript if I can. I mean, I don't even know if I can. Well, I know I can, but I haven't done it yet. So let's figure it out. Anyway, let's take a look at some of these scripts, because the more proficient I become in RhinoScript editing in this Python, the better I'm going to be when the nodes come in. So let's take a look at what this one does. This is a script that imports the Rhino syntax as RS. It iteratively scales down any curve. This curve, and this curve, which I made by just trimming a bunch of 3 curves together. I guess you could have done a region union or something like that. I may do that in Grasshopper. But either way, you get to a curve, you're able to grab it, and you're able to scale it down smaller than what it was to a certain scale. So if I went in here, for instance, and hit play, it's going to say, well, I think I have to leave the script first. Let's hit play. It's going to say, select the curve to refit this one, and it'll say you can have a maximum limit up to 11, because that's what it is, so you can scale it down. I'm just going to scale it down to 8 and hit enter, and watch that little thing shrinks down to here, and there it is, all shrunken. So that's what the script does. So you can go back in, you can leave it, you can hit play again. Actually, since I'm on that square, I probably want to exit that, leave, and I guess if I pre-selected this one, I could just go in and hit play, and it will say what size do you want to take it to, and I'll take it to 12, and there we go, it scales down again. So you can just keep playing with this as you go. Same thing again and again. So import RhinoScript syntax as RS, comment, so it's not reading the script, as you know in Python, hopefully, iteratively scale down a curve until it becomes shorter than a certain length. So you're writing a function called fitCurveToLength, and that's exactly what I'm typing in, a length, and it fits the curve to that length, keeping it in proportion to what it was beforehand. The curve ID is a variable that is defined by the RhinoScript getObject tool, but I put in a command line, which will appear up here, which you saw. Select a curve to fit to length, and then it has to be true and true for the filter of that curve, the RhinoScript filter of that curve. Then you go into this conditional, if curve is none, then return. So it means nobody entered a curve, so let's get out of it, so it doesn't just have a problem or have an error. The length is set to the curve length of the curve ID. Well, that makes sense. We grab that as soon as we select it. It gathers that information. The variable of length limit is set to the RhinoScript getReal length limit, which is going to, that's what comes up in those little tiny markers. And it will set that to 0.5 times length and 0.01 times length, and then return that length. And if length limit is none, once again, if nobody's put that in, then it returns and you exit this tool and you're back out of it. The real loop comes here, and this is the real excitement, they say. While true, so while you do have this, while it's happening and the jive is going on, if the RhinoScript curve length, curve ID is less than the length limit, otherwise it will break. Which it leaves the code. So if I type in a number higher than what it suggests, it'll leave that. Otherwise, your curve ID is then reset to the scaling the object of the curve ID around XY. So you don't have to scale it back to 0, 0, 0. You can go into the script and you can scale it around whatever you want. We could scale it around, let's just do this for fun on the last one. Let's scale around 10, 10, 10, and it might leave the page. And there's your scale value of 0.95. Let's hit run and choose this one to fit, and if we scale it to 12, it should shoot off in the direction of where to go. Well, it went way over here because it's scaled to 10 by 10. So that's just something to think about. I don't know if I can go back, so that's cool. Yeah, I don't usually do anything in Rhino. Once again, for those that know me and see me do Grasshopper, I have not come at learning Rhino first. I've learned Grasshopper, I've learned Python, and now I'm going back into Rhino to learn Rhino script. And I'm not that proficient as a CAD designer. I simply want to know things in their more automative state of programming. And didn't know that was in me for the last 30 years, but I definitely know, judging by the videos I've been eager to put online, the time I spend online daily on Grasshopper, and I certainly didn't know I'd be home for the COVID-19. This is all blown up in my face. If curve length is none, then you will print something went wrong, which means you didn't get any data, and it will return that. If not, it will print new curve length, and there you go. It will tell you exactly what that is. And this is a function that they list in here that I didn't understand, the name and the main fit curve length function. And what that is line 2022. Eventually, all curves will become shorter than the limit length while loop. We print this other message. Where do they talk about that? Thought I saw it in here, but maybe I got ahead of myself, or maybe I reordered my paper. Yeah, here it is. What's happening in this line? This is where the viewport. They talked about it in the script before this, which was dealing with a loop that never ended, and it was dealing with a clock. But I'll try and relate it. In Iron Python, the main function call must be executed after the definition of the function. So this has to come after we exit the scope of this function. So I'll just read through that. If the if name set to or equals, in quotes, the main, with those dash lines on each side of it. I mean, you have to keep in that same, those double dashes before and after the name and main. This trick exists in Python so that our Python file can act as either reusable modules or standalone programs. So that's something that's, it's new to me. I got to wrap my head around it. But it's a very playful little script. It's actually starting the script to bring geometries in here. I'm going to try it out in Python, see if I have any success as part B. If not, I'm going to keep moving on. I'm going to do some incremental loops, and I'm going to generate some other geometries which come to mastering that loop. And then we'll go on the tuples, lists, and dictionaries. But I'm happy to do this because I played around with processing a bit, and it's nice to be able to bring this into the three-dimensional realm of Rhino, and then think about all the things I can do prior to needing this script to activate, say, in Python or in the Rhino script, and then what I can do after these circles as well. So not sure where the application is. I'll leave that up to you. Thanks very much for watching.